This is the notes video for Module H, Unit 1, Lesson 1. The topic is Intro to Matter. In your notes underneath the vocabulary, you've got a bold heading that says Notes, and right underneath it, it says Matter equals. And we learned in this lesson that matter is anything that has mass and volume, or we can say anything that has mass and takes up space. Then in the notes, there are 4 squares. Each one has a heading in it, and we'll fill in each of the squares individually. The first square says density. Density is equal to mass divided by volume. And an important conversion that we'll come back to in a little bit, 1 milliliter of liquid volume is equal to 1 cubic centimeter of solid volume. So that means that we can measure density in either grams per cubic centimeter or grams per milliliter. Remember to make that little 3, it's called a superscript. You highlight it and hit Control period. And then when you're done and you want to go back to regular font, highlight again and hit Control period a second time. The next square is volume. Volume is the amount of 3-dimensional space an object occupies. And the formula we saw in the lesson was volume equals length times width times height. That can be abbreviated V equals L WH. Volume in the metric system is measured in cubic centimeters for a solid object or milliliters for a liquid. And that is an important conversion. If you have 1 milliliter of liquid volume, that's equal to 1 cubic centimeter of solid volume. That'll be helpful when you're doing the lab and you need to measure the volume of an object by water displacement. Then mass is the third square. Mass is the amount of matter in an object. We measure mass with a balance, and we measure mass in grams, a lowercase g. And then this graph comes from an illustration in the digital lesson, and it's showing us that when an astronaut is headed into space, no matter how far away they get from Earth, their mass remains the same. In the digital lesson, mass was a red line, and those of you that are visual learners, it might help you to keep the same color. Another way that I've explained this in class is that mass is a measure of all the stuff that's in me. So my bones, my organs, my blood, my ligaments. And when I travel into space, those things still stay in me. So my mass remains the same everywhere in the universe. In contrast, weight changes. Weight is a measure of the pull of gravity on an object. Weight is measured with a scale. And weight is measured in newtons in the metric system, uppercase N. So when you travel into space, the further you get from Earth, the less you weigh because there's less gravity the further you get from Earth. So this line, I can't get the screen shade to disappear, but it says distance. In the digital lesson, this was a green line headed down, showing that weight decreases. You've seen astronauts kind of bounce on the moon because of their decreased weight in space. So again, mass is constant. It stays the same no matter where in the universe you are, but as you travel farther away from Earth, weight will continue to decrease because there's less gravity. Then we talked about measuring the volume of an irregularly shaped object. We've got that formula for volume, length times width times height, but sometimes objects can't easily be fit into that formula, say a toy dinosaur or a rock. In that case, you would fill a beaker with water and measure the amount of water that you start with. Then add the object carefully to that water so you don't have any splashes. That would affect your results. And measure the new volume. See where the water level hits then. And then you need to do some math. Subtract the original volume of the water from your new volume, and that will give you the volume of the object. And then one thing I don't have in the notes here that you do need to do is change your label, because you measured the displacement of a liquid, water, but you want the volume of a solid object like a toy dinosaur. So you would change the label from milliliters to cubic centimeters, and then you're done.